Hello guys, so in this video we are gonna start solving the basics of algebra. We're not solving any question papers here, we're solving the entire concept for algebra. So in our Maths B algebra, there are these much topics that are submerged under the algebra heading. Like there is linear, quadratics, word problems, and then inequality, direct variation, changing subject, factor remainder theorem, LCM, factorization, simplification, evaluation, and sequence, right? So these are the concepts that are basically that actually comes under the algebra heading. So in this video we are going to solve the linear equations and indices and simultaneous equation and quadratic equations, right? So I'm going to follow this book. So this is the start for the linear equations. So we are going to start with linear equations. So for linear equations, if I go back to this PDF book, there are certain questions. Like for example, question number 10 wants you to find the value for x by solving this equation, right? So question 10 is, I'm just going to copy question 10 and then give you the solution in the Word file. So we are solving the question. Let me assume that this is question 1 for our linear equation. So question 1 for our linear equations. The question was 2 3x minus 4 and then 1 minus 3x is equal to 3x plus 4. Right, so at first what we need to do is that we need to exclude the brackets. That is, we need to multiply the 2 with everything inside the bracket and then 4 with everything inside the bracket, and then again the same thing for 3 with everything inside the bracket. So we need to multiply 2 with 3 and 4, 4 with 1 and 3 here, and then 3 with x and 4. So if you just do this, 2 into 3 is 6x minus 8. And this becomes 4 minus 4 into 1 is minus 4. Minus 4 into minus 3 is positive 12x is equal to 3x plus 12. Right. So if you just then add all the x's together, so you have like 6x plus 12x. And if you just shift this 3x from the right hand side to the left hand side, it will be minus 3x. And on the left hand side, so on the right hand side, there will be 12. And all these minus 8 minus 12 is shifted to the right, so it will be positive 8 and positive 4. So eventually it will be 6 minus 3 is 3, and 3 plus 12 is 15x equals to 24. The final answer would be x equals to 24 over 15, and if you calculate it, the value for x is going to be, like, simplify of this fraction is going to be 8 over 5. Right, so this was the solution for linear equations. Linear equations are very simple. Linear equations just only have a single line of equation where the power of the alphabet is going to be 1. You just need to multiply the concepts together, multiply the numbers together, and then find the value of it. Like, simplify the equation to find the value for x. And linear equations always doesn't contain just the concepts for multiplication. They will also contain the concepts for LCM and fractions. So if you just move to another question that is involved with fraction. For example, down here, this question is involved with fraction. So if you solve this question now, so this question was about x minus 4 was the numerator and denominator was x plus 7 is equal to x minus 2 divided by x plus 3. So now if you just cross multiply the concept, like cross multiply the values together, then you will get x minus 4 multiplied with x plus 3 is equal to x minus 2 multiplied with x plus 7. So the final one is, when you multiply these things, it will look like you are multiplying x with the entire x plus 3 and again 4 with x plus 3. And same thing goes for the right hand side, x multiplied with x plus 7 and minus 2 multiplied with x plus 7. So if I just break this down and write this in detail, the entire thing would look like x is multiplied with x plus 3, and then you had minus 4, that would be multiplied with x plus 3, and then you have x multiplied with x plus 7, and then again you have minus 2 multiplied with x plus 7. So when you multiply this, like x multiplied with x becomes x square plus 3x minus 4x minus 12, and then on the right hand side it will be x square plus 7x minus 2x minus 14. So when you just simplify all the things together, like on the left hand side you have x square minus 4x and plus 3 gives you minus x and minus 12, and it will have x square minus plus 7 minus 2 is going to be plus 5x minus 14. So if you just take everything on the right left hand side, so you will have x square minus x minus 12, and then x square minus 5x plus 14 equals to 0. So the x squares get cancelled out. You are left with minus x and minus 5 gives you minus 6x. Minus 12 and plus 14 gives you plus 2 equals to 0. So if you now just make x the subject, it will look like this, and just x the subject, so it will eventually be minus 2 by minus 6. So the final value for x is going to be 1 over 3. Right, I obviously extended this maths a lot. I mean, if you don't need, you can obviously skip step 2 and step 3. Step 2 and step 3, I just wrote it down to explain every concept for this type of maths, right? So if you don't want to show these steps, that's totally fine. You can certainly skip step 2 and step 3. So if this was clear, this was another type for linear equation. Linear equations are going to be simple multiplication, just like in our question 1. Linear equations are going to be fractions, just like in our question 2, and again there will be LCM also for linear equations. So if we move to this part and like do questions from this, like this question number 2, they have LCM here. So if I now solve this question, like this will be our third question for linear equations. So question 3, the entire question was given like 1 over 3 multiplied with x plus 2, and then again minus 1 over 4 multiplied with x minus 1 equals to 2, right? So you can obviously write these fractions in improper fraction, like they are given in the mixed fraction. You can write it down as simple fraction, that is this x plus 2 and x minus 1 will be multiplied with their respective numerator. Like this x plus 2 will be multiplied with 1, but it won't make any significant difference, so we can just simply write x plus 2. If it was getting multiplied with something other than 1, like any number, then obviously we would write that multiplied form. But as it is just multiplied with 1, so there is no change in the numerator, like it will be just x plus 2 or x minus 1. So now you have two fractions, and the two fractions have different denominators. Always remember, like when the two fractions are either added or subtracted, you have to do LCM. Now the LCM for consecutive number, like 3 and 4 are consecutive number, right? So you cannot do the LCM for consecutive number. The LCM for 3 and 4 would be just the multiplication of the two numbers, that is 3 into 4 is going to be 12. So the final LCM is going to be 12. And in order to multiply, like make the denominator same for both, you have to multiply 4 with x plus 2, and again we have to multiply 3 with x minus 1 is equal to 2. And now if you just simplify this, like 4 into x plus 2 would be 4x plus 8, and minus 3 into x minus 1 would be minus 3x plus 3. Now if you just change this denominator from change the side of the 12 from the left to the right hand side, it will be multiplied. So 2 into 12 is going to be 24. 4x minus 3x is going to be just x. 8 plus 3 is going to be plus 11, and this is going to be 24. The final value for x would be 24 minus 11, and if you subtract 24, like 11 from 24, you get 13. So the value for x is going to be 13. So this was another example for linear equation where you have to do LCM for the two fractions and then move to the simplification, right? The concepts are same for the three different types of linear equation that will be asked in your IGCSEs. The first one is simple multiplication. So this one is an example for simple multiplication. This one was an example for simple fraction. And this one was the example for LCM fractions, or fractions where you have to do LCM and then do the calculation. So LCM fractions. So this was all the type of different linear equations that will be asked in your IGCSEs. So now linear equation is done. So if I just move to this one, we are done with linear equations. Now we are going to move with indices. Now indices is also included in our specification under algebra, but it is not written in the screen, written in this PDF. So let me just write it down over here. Indices. Right, so we are done with linear equations. So indices is there actually, just added with the linear equations. So we are done with linear equations, and now we are going to move with indices. So indices are basically maths that are involved with power math. For example, if we solve question number 1, there it says that given that 2 power 3x is equal to 64, you need to find the value for x. Right, so this is going to be our second concept for the video. Indices. So for indices, our question 1 was 2 power 3x was equals to 64. Now what we do is that we try to express 64 as a power of 2. Like if you make 2 to the power 5, you get 32. If you calculate the value for 2 to the power 6, you get the value for 64. So you can obviously write 64 not just as in the 64 format, but you can write it down as 2 to the power 6. Now what happens is that the two bases of the equations are equal. So you can obviously automatically cancel out the two bases. So you can just cancel out the two bases, and you do not need to draw these lines for this. Like you're cancelling the value for two bases. You do not need to show that in your max copy. So you can just write it down as 2 to the power 6. After this stage, you just can move the power to the base. So you can write 3x is equal to 2. You do not need to write the statement that you have cancelled the two bases as they were similar. You just can move to the next step, that is shifting their powers in the base stage. So now if you make the subject x the subject of this equation, it will be 6 over 3. So the value for x would be 2. Right, so that's how you solve indices. Now this was a very easy question to work with. There will be little trickier questions than these one. Like if I move to the second questions, for example, maybe question number 5 from the PDF, where it says that express 243 as a power of 3. So obviously we can express 243 as a power of 3. For example, 3 power 5 gives you the value for 243, right? So you can do the value 3 power 5 gives you the value for 243. So if you move to solve B, there is another question given. So if I solve question B now, I'm just using it as question 2 for our PDF. So 1 over 3 and 3 minus 1, there was a power for 3 was 3x minus 1, is equal to 243 with a power of x. right? So for this one, you need to solve like as this 3 was at the denominator. Always remember, like for example, if the expression is like this, you can write it down as a power minus 2. When you move the denominator to the numerator stage, the value for the power becomes negative. Like for the first stage, a over a 1 over a square, right? Here the power is positive, but when you move that a to the numerator, the power becomes negative. So you can write it down this as 3 minus 3x minus 1. The entire power was 3x minus 1, and when you shift that denominator to the numerator, the power becomes negative. And also you can express 243 in terms of 3 to the power 5. So it will be 3 to the power 5 with x. And again, another thing to remember is that whenever like this, the entire maths is like this, a over m and then another power, the two powers will be multiplied in this form. Like you need to multiply m and n together. So this is one of the rules. So now again, if I just try to simplify it, write it simply, the minus will be multiplied with everything inside the bracket. So it will become negative 3x plus 1, and this will become 3 power 5x. Now if the two bases are similar, in the question the two bases from the two other sides are similar, so they will eventually get cancelled out, and the final powers will look like minus 3x plus 1 is equal to 5x. Now if you move the 5x to the right hand side and 1 to the left, it will be minus 3x minus 5x equals to minus 1. So you will get the value for minus 8x equals to minus 1, and the value for x would be positive 1 over 8, right? Because the minus minus gets cancelled out, and the value for x would be 1 over 8. So this was another tricky question for indices. If you move to another question for indices, for example, question 7, where they are using roots, always remember root means 1 over 2, half power, right? So they have equation of 5 minus root x equals to root x minus 7, which there is an equation they are using. Question 3, 5 minus root x equals to root x minus 7. So if you just take all the root x together, so it will look like root x minus root x equals to minus 7 minus 5. So you have 2 root x, right? So you can just write it down as minus 2x power half is equal to 7 minus 7 minus 5 becomes minus 12. So if you just make x power half the subject, it will be minus 12 over minus 2. So x power half becomes positive 6. And now if you move this entire half power to the right hand side, whenever you are shifting half to the right hand side, it becomes square. So the value for x would look like 6 square, and finally the value for x is going to be 36. Right, so that's how you solve all the indices maths. I hope the indices type of maths were clear enough. If I just show you another one, like for example in our question 4, we are given an equation as a power 6, and there is a further power on it, that is minus 2 over 3, and this is going to be 1 over a power m. So when you multiply whenever the powers are in this bracket form, they are actually in the multiplied form. So you have to multiply 6 with 2 over 3. So 6 into minus 2 over 3. So when you calculate it, you get a value of minus 4. So this becomes a power minus 4. After multiplying the 6 with 2 over 3, you get minus 4. And obviously we can write a power m as a power minus m in the numerator form. And now you can see that on the both hand side, the bases are equal, a and a, so they get cancelled out. So you are left with minus 4 equals to minus m. So the final value for m would be 4. So this is how again you calculate the indices type of maths, right? So the indices type of maths are quite easy. They do not have that much of a pattern to follow with. So we are done with the two topics for algebra, that is linear equations from the start here, and now with indices. So we are now going to move with simultaneous equations. Simultaneous equations are mainly maths that are involved with two equations that have multiple alphabets in them. So simultaneous equations look like this. You will be asked, you will be given two equations and then asked to calculate the value for the x and y. So if you move to question number 2, you can see there are two equations. First one, 5x plus 2y equals to 16, and the second one is 4x minus 3y equals to minus 1, right? So if we solve our question number 1, that was 5x plus 2y equals to 16, and again the second equation was 4x minus 3y equals to minus 1. So we can solve simultaneous equation using two methods. So the methods are, first method is elimination, and the second method is substitution. So these are the two methods by which you can solve simultaneous equation. So I'm going to solve question number 1 with both processes so that you can identify the difference between elimination and substitution, and then I'm going to solve multiple other questions to give you the grasp idea for simultaneous equation. So if we solve question number 1 first with elimination, what we have to do is that this is our, let me label the equations as this is equation 1 and this is equation 2. As we can see that both the equations have two unknown alphabets, right, like x and y. So what we have to first do is that we need to eliminate one of the two alphabets. For example, if I want to eliminate x from the two equations, what will I do is that I will multiply equation 1 with the coefficient of x from equation 2, and I will multiply equation 2 with the coefficient of x from equation 1. So the coefficient of x on equation 2 is 4, right? This is the coefficient of x on equation 2. So I'm going to multiply equation 1 with 4, and the coefficient of x on equation 1 is 5. So I'm going to multiply equation 2 with 5, and then I can just write a sentence that eliminate equation 2 from 1. So I'm just going to write eliminate equation 2 from 1. So this equation will look like after multiplying the equations with 4 and 5 respectively, the equations will finally look like 4 into 5 is 20x plus 8y is equal to 16 into 4. You get 64. And again multiply the second equation with 5, you get 20x minus 15y is equal to minus 5. So when you try to eliminate the equations, you have to write a minus sign in front of them. So you can see that my 20 minus 20, they gets cancelled out. This red minus, what actually happens is that plus 8 minus 15, and you are adding another minus with it, right? So the 15 becomes positive, like minus the 8, this minus in the bracket that I externally added, it doesn't get involved with the upper one, it gets involved with the lower number, like the negative 15. So when you are adding another minus with minus 15, you will get positive 15. So the final one would be 8 plus 15, and the final answer would be 23y. So this one here becomes 23y. And again the same concept, this red minus will not get involved with the 64, it will make the negative 5 positive. So when you add 64 and 5, you get 69. and you just have to make y the subject of it. So it will be 69 over 23, and the value for y would be 3. The value for y is 3. So this is how you first eliminate the one. So the main concept for multiplying the two equations with the consecutive coefficients of x is because that we wanted to eliminate x from the equation, so that we can only focus on the one alphabet. That we focused on y, so we get the value for y. And now we need to substitute the value for y into any of the desired equation you want, and then make x the subject to calculate the value for x. So for that also you need to write another statement, like substitute y equals to 3. I am choosing equation 1, equation 2. Right, so the equation 1 was 5x plus 2y equals to 16. So it is 5x plus 2y equals to 16, and when you input the value for y into the equation, it will be 5x plus 2 bracket 3 equals to 16, and if you just try to make x the subject, it will be 16 minus 2 bracket 3, and the final x would be 16 minus 2 3 over 5. So 16 minus 6 is 10. 10 over 2 is the value for x is 5. So the value for x is 2, sorry. So these are the two values for the unknown alphabets given in the question, right? So finally you can write your answer as y is equal to 3 and x is equal to 2. So this is how you calculate the value for the unknown alphabets, multiple unknown alphabets inside a equation using the elimination method. So this was the elimination method. Now if I solve this same question using the substitution method, so that you guys can just compare the difference between elimination and substitution. So the question is going to be same, 5x plus 2y equals to 16, and the second equation was 4x minus 3y equals to minus 1. So I'm going to again label the two equations as equation 1 and 2. So for substitution, what is the different step that we do is that we are going to make a third equation from any of the equation. So I'm going to make a third equation from equation 1. So we can say that from equation 1 was 5x plus 2y equals to 16, and if I try to make x the subject, it will be 5x 16 minus 2y, and the value for x, the equation for x would be 16 minus 2y divided by 5. So this is the equation for x. Now we are going to label this equation as equation 3. Now always remember that you can make equation 3 from any of the equations you want, from equation 1 or equation 2, it really doesn't matter. But whenever you make equation 3 from equation 1, you cannot input this equation into equation 1. For substitution, what we do is that we use the third equation and input it in the second equation to get the value for y. So we are going to substitute this equation 3 into equation 2. So the equation 2 was 4x minus 3y equals to minus 1, and the value for x, the equation 3 was actually giving me a value for x, right? Because x is equal to 16 minus 2y over 5. So equation 3 was nothing but a value for x in terms of y. So you can use this value and input it in equation 2, wherever equation 2 has x, you can just input the value for x into the equation. So we can write instead of x, we can write the value for x, that was 16 minus 2y equals to 5 minus 3y equals to minus 1. Now what happens is that we have totally eliminated x from our equation. Like if you see the derived format where I inputted the value for x instead of x, you can see that now the equation only has one alphabet, that is y. There is no x anymore in the equation. So this was our entire motive, that we are gonna eliminate x by substituting the value for x into the equation, so that equation is just now focusing on one alphabet. So now if we multiply this thing, 4 into 16 would be 64 minus 8y divided by 5 minus 3y equals to minus 1. Now obviously I have to make do LCM, because 3y is not in fraction and 64 minus 8y by 5 is in fraction. So if this 3y doesn't have anything in denominator, we always assume that it has 1 at the denominator. So the final LCM of 5 and 1 would be 5. So this 64 minus 8y doesn't have any change, but this 3y will be multiplied with 5 and is equals to 1. Then we are going to shift this denominator 5 to the right hand side, so it will get multiplied with 5, so with 1, and you will finally get 64 minus 8y minus 15y is equal to minus 5. So if you just calculate the value for y, like minus 8 minus 15 is going to be minus 23y, and shift this 64 to the other hand side, so it will be minus 23 minus 69, and the value for y would be minus 69 over minus 23. So the value for y is actually going to be 3 again. So this is how you solve the value for y, and again you have to input this value into the third equation. Now you can input the value for y into any of the three equations above, but I am choosing the third equation because third equation has already in the third equation x is already in the subject, right? So we do not need to do any changing subject concept. So that's why I'm choosing the third equation. So you can just write it down like this now, that substitute y equals to 3 into equation 3. So the equation 3 was like x equals to 16 minus 2 would be 3 divided by 5. So the final value for x is again going to be 2. So now it really doesn't matter which method that you are using, that you're going to use, either substitution or elimination, the value for x and y is going to be same. Right, so I used one equation and I used one question and solved that question into both elimination and substitution, so that you can see the difference, that how you would solve the simultaneous equation using elimination method and how you'd solve the simultaneous equation using substitution method. So in elimination method, you multiply the coefficient of a certain alphabet in interchange with respectively with the other equations, and then you eliminate one equation from the other so that you can focus on only one alphabet, and then you get the value for one alphabet, and then you substitute for that value into any one of the equation, right? And for substitution, you choose any one of the equation and then make a third equation from a certain equation, and then you input the third equation in the other equation, and then you simplify the equations to get the value for one alphabet, and then you use that value for alphabet and input it into the third equation to calculate the value for the other alphabet. So for substitution, you have to make third equation. For elimination, you have to multiply the coefficients together, right? So these are the two ways by which you can solve simultaneous equations, either by elimination or by substitution. Now let me write it down over here. This one is the elimination method. And this one is the substitution method.